So I did reflection. This is all reflection. Then I did rotation. This is all rotation. And then I ended the session by explaining translation. Let's start with enlargement. In enlargement, there are two things. One is scale factor, which is represented by K, and other is center of enlargement. Because it is X comma Y. Now, scale factor can be positive. It can be negative. Positive scale factor means, let's suppose your center is here. Your object is above the center, so the image is also going to be above the center. If the center is to the left, object is to the right, image will also be to the right. Center is here, object is to the left, image will also be to the left. Negative factor means center will be in the mid. Meaning, this is the center, this is the object, this is the image. This is the center, this is the object, this is the image. So they're going to be on the opposite sides. Another thing is that if the scale factor is between -1 and 1, your image will be diminished. Diminished means smaller image. And if your scale factor is greater than 1 and less than -1, means, for example, K is 2, 1.5, -1.5, -3, +3. So your image will be larger. Now, let's just do a question. You have to enlarge this object about the center by the scale factor +3. So the step 1 is going to be take column vectors from the center, just like rotation. Yani ke, if I take the column vectors, it's 0, 2, 3, and then 2. 1, 1, 2, 3, 4. Step 2 is going to be multiply all of them with the scale factor. So 0, 6, 9, 6, 3, 12. So 0, 6 means 3, 4, 5, 6. 9, 6 means 3, 6, 9, and then 6, 1, 3, 6. 3 and then 12, 3, 6, 3, 6. So this is your enlarged image. Let's take another example. This is the center. So let's take the column vectors 3, 0, 4, 0, 1, 2, 4, and 2. अब हमारे पास क्या चीज़ है? Multiply by the scale factor. -6, 0, -8, 0, -2, and -4, -8 and -4. So -6, 0 would mean 3 and 3, 6. 6 and -8, 0. -2 and then -4. -8, 4 and -4 and then -4. So you can see when the scale factor is negative, the image is also inverted. So it's an inverted image here. All right, let's move on to, so we are done with reflection, rotation, translation, enlargement. When the object is given along with its conditions, how to draw the image. Now the next thing is going to be when you have the object with you, you have the image with you, you have to identify the transformation, and you have to write down the conditions. Conditions in case of reflection is going to be line of reflection. In case of rotation is going to be angle, direction, center. In case of translation, it's going to be translation vector. In case of enlargement, it's going to be center and scale factor. All right, so we were discussing when you've been given the object and image, you have to write down the conditions. Let's take a few example questions now. The diagram shows A and B. Draw and label triangle C. Translation with vector 3 and -1. So 3 -1, 3 -1, 3 -1. So this is going to be your C. A is mapped onto B by reflection Q. Write down the equation of the line of reflection. So if you have to draw the line of reflection, first you have to do is join the corresponding image and object points. Over here, they have already mentioned that it's reflection. If they don't mention reflection, you know that all object and image lines are parallel to each other, just like in this case. Now, how do you identify the line of reflection? Find out the midpoints of these lines. So the line of reflection is going to be this line. Right? Take its example, write down its equation. The equation of this line is y is equals to x. How? Because 1, 1, 2, 2, 3, 3. So I know that this line is called y is equals to x. C is mapped onto D by a reflection Q. So that it's the same reflection of C under this line, which maps B onto D. So the first thing is you have to draw D. Point on the line of reflection will remain here. We'll go here. And this is going to be, all right, so if I redraw this, 3 and then -1, this is like this. Yes. So it's going to be one diagonal, one diagonal. This is D. So they're saying B onto D. So I can say that exactly isko yahan se utha ke yahan rakh diya gaya. So it means it is translation because the object has not rotated or inverted or nothing. So B onto D, the translation is going to be from this object to this image. It's 1, 2, 3, 3 up and -1 left. So B onto D is translation with this vector. That's how we identify. All right. Transformation R is a reflection in the line y is equals to 0. Now, what is meant by this? R, Q, A is equals to E. So A undergoes Q transformation. Image undergoes transformation R to give final image of E. Okay, so A has to undergo Q. So jab A ko aapne Q ke undergo gaya, so we get B. Now B needs to undergo the transformation R, which is y is equals to 0 ke andar reflection. Y is equals to 0 is this line. Is line ke andar reflection karte hain, so this is what you get. So this is called E. Now they're saying find the coordinates of the vertices of E. So E is going to be 4, 0, 2, 0, 4, -1. That maps A onto E. Now they want A onto E directly kya ho raha hai. So I think A onto E is directly, I think it is rotation. So I'm going to remove all of these lines, especially the reflection line, because that's not required in the question. And the rest of the diagrams need to be drawn. You can also remove them because they're not asking you. No, C needs to be drawn because unhone kaha hai C draw hua hona chahiye. All right, so if I make the perpendicular bisector is going to be this for this line, and for this line is going to be somewhere here. So it's rotation. Rotation, center 0, 0, and rotation center 0, 0. It has moved from A to E, so it means 90-degree clockwise. Find a matrix which represents the transformation that maps A onto E. So 90-degree clockwise rotation means X, Y changes to Y minus X. That gives you 0, 1, -1, 0 as the matrix. So we have to study matrix transformation, which I'm going to do right after this question. Let's look at this. Enlargements is 1, 2. Scale factor 1.5 maps A onto P. So this point will remain 0, 0. This is 4, 6. And then 0, 6. When you multiply this thing by 1.5, 6 into 1.5 gives you 9. So 0, 9. So 6, 4, 6, 3, 6, 9, 9. And then this is also going to be 9. So this is your A part. This is your triangle B. Enlargement with scale factor minus 0.5. Minus 0.5 would mean minus 2, minus 3. And 0, minus 3. Minus 2, minus 3. 0, and then minus. So I'm counting the number of boxes. I'm not looking at the coordinates. So you also do the same, okay? Area of triangle C is to B. So C ka area is half into base is 2 into 3 is height. Half into 2, 4, 6, 2, 4, 6, 8, 9. 6 into 9. Divided by 0.5 into 6 into 9 gives you 1:9 is the ratio. All right, let's study matrix transformation now. In matrix transformation, you need to know certain matrices, which are reflection in x-axis, x comma y changes to x comma minus y. So this makes you 1, 0, 0, minus 1. Y-axis, x, y changes to minus x comma y. Minus 1, 0, 0, 1. Y equals to x, x, y changes to y comma x. That gives you 0, 1, 1, 0. Then y equals to minus x, that gives you x, y changes to minus y comma minus x. So 0, minus 1, minus 1, 0. Rotation 90-degree clockwise. You know that x, y goes to y minus x. So 0, 1, minus 1, 0. 90-degree anti-clockwise means x, y goes to minus y, x. 0, minus 1, 1, 0. 180-degree means x, y goes to minus x, minus y, 0, minus 1, 0, 0, and minus 1. Now for enlargement, it is, some people say it's Cook, where K is the scale. Now the formula for matrix transformation. For these matrices, you have to remember them and they will ask you to write down these matrices directly. Test in the previous question, they say state the matrix. So matrix state karne ka matlab ye hai ki 90-degree clockwise, you should know what the matrix is going to be. Formula for matrix transformation: matrix into object coordinates give you the image coordinates. This is for reflection, rotation, enlargement, or any other transformation. Only for translation, it is object coordinates plus translation vector gives you the image coordinates. So let's suppose S is a transformation matrix minus 1, 0, 2, 1. Find the coordinates of A under this transformation. And I'll just make A right. So the first coordinate is 3, 4. These are not column vectors. These are coordinates that I use in matrix transformation. 5, 2, 2, 2. Let's take these coordinates. Matrix into the object coordinates. Minus 1 into 3. Minus 1 into 3 plus 0 into 4. 2 into 3 plus 1 into 4. So this gives you minus 3. 6 plus 4 is 10. Now, minus 1, 0, 2, 1. I can use both these coordinates together as well. 5, 2, 2, 2. First row, first column. Minus 1 into 5 plus 0 into 2. Minus 1 into 2 plus 0 into 2. So I did first row, second column here. 2 into 5 plus 1 into 2. 2 into 2 plus 1 into 2. Minus 5, 10 plus 2, 12. Minus 2 and 2 times 2, 4. 4 plus 2 is 6. So for this coordinate, the image is this, and for this coordinate, the image is this. So it's minus 3 comma 10, minus 5 comma 12, minus 2 comma 6. So these are the coordinates of A under this transformation. This is the image coordinates. They can also ask you to plot them. You can also plot them on the graph. Now the next question is going to be this. Let's say under this transformation, let's say this is B, image B. So A onto B, it is minus 1, 0, 2, 1 matrix. Describe the matrix which maps B onto A. So you have to go backwards. You have to go from B to A now. So B to A means inverse of the matrix. How do you find out the inverse of the matrix? It's minus 1, 0, 2, 1. AD minus 0. The determinant is minus 1. Switch the positions, change the signs. 1 upon determinant. That gives you minus 1, 0, 2, 1. This is going to be your S inverse, which describes B onto A. A few rules of matrices. When you multiply the matrix by its inverse matrix, the answer is always the identity matrix. What is the identity matrix? It's 1, 0, 0, 1. When you multiply a matrix by identity matrix, it does not change. The point A has coordinates 2, 3. What happens under my, and my is reflection in y-axis. Y-axis make it goes to minus x, y. Find the coordinates of MD, MYA. So MYA is minus 2, 3. And MD is reflection in the line y is equals to minus x, which makes it you shift the coordinates and you change the signs. The inverse of R90 maps B onto A. So B onto A. So A onto B is going to be the normal R90. So R90 means rotation anti-clockwise around, which changes minus y to x. Write down the matrix which represents mx, reflection in the x-axis. X, y goes to x comma minus y, so 0, minus 1, 1. 1, 0, minus 1. 1, 0, minus 1, 0. This is going to be my 2 ka E part. Which single transformation is equivalent to mx and R180? So mx changes xy to x comma minus y. Then R180 maps minus x to y, which is clearly reflection in y-axis. See, so you can say my. Okay. Point P and Q have coordinates 4, 0, 9, 0. This is right on the length of PQ. x2 minus x1 the whole square plus y2 minus y1 the whole square. You can do the same thing for this one. By a single rotation, by using the grid below, find by drawing the coordinates of the center of this rotation, measure the clockwise angle of rotation. So you by drawing, that means you'll be given the grid and you will go ahead with the whole process.